Example, a ball is thrown vertically upward with a velocity of 2 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. A. How high will the ball rise? And B. How long it be before the ball hits the ground? Take G equals to 10 meters per second square. The situation is shown in the figure. This is a ground and this is the tower. Point of projection at this height, that is at a height h, ball is thrown in upward direction, and we have taken the sign convention: upward direction as positive and downward direction as negative, and rightward direction as positive and leftward direction as negative. At maximum height, because at maximum height v will be 0. Now here u equals to, because initial velocity is an upward direction, so we have to take with positive sign, plus 2 meters per second, and v plus 20 meters per second given, and maximum height, because v will be 0, so v equals to 0. Now gravitational acceleration due to gravity is acting in downward direction, so it will be negative, so g equals to minus 10 meters per second square. Now we can use the formula v square equals to u square plus 2as, or u square plus 2gs. Here v equals to 0, u equals to plus 20, using sign convention, v equals to 0, u equal to plus 20 meter per second, g equals to minus 10 meter per second, and so s equals to x. Thus 0 square equals to 20 square plus 2 into minus 10 into x. After solving, we will get x equal to 20 meter. Second, we have the formula s equals to ut plus half at square. So we can use h equal to ut plus half gt square. Now here, finally ball comes on the ground, that is displacement is negative. So here we are using negative sign, and u equals to plus 20 meter per second, because initial velocity is in upward direction. G equals to minus 10 meter per second square. Putting all the value, like minus 25 equals to 20t plus half minus 10 into t square, and going in this way, finally we have this equation: 5t square minus 25t plus 5t minus 25 equals to 0. Taking common 5t, t minus 5 plus 5 into t minus 5, which reduces to this form: t minus 5 into 5t plus 5 equal to 0, which gives t equals to 5 and t equals to minus 1, because time can't be negative, so answer will be 5 seconds. Since t equals to minus 1 is acceptable, so t equals to 5 seconds. Now free fall. A object released near the Earth's surface is accelerated downward under the influence of the force of gravity. The magnitude of acceleration due to gravity is represented by g. If air resistance is neglected, the object is said to be in free fall. If the height through which the object falls is small compared to the Earth's radius, g can be taken to be constant, equal to 9.8 meter per second square. Free fall is thus a case of motion with uniform acceleration. Now Galileo's law of odd numbers. The distance traversed during equal intervals of time by a body falling from rest stands one another in the same ratio as the odd numbers beginning with unity, namely 1 is to 3 is to 5 is to 7 is to dash 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 dash. Let let tau be the equal intervals of time of an object under free fall. Consider the object is falling with zero initial velocity. The equation of motion is h equals to ut plus half gt square. Here u equals to 0, g equals to minus 9.8 meter per second square. Hence distance travel in first tau second will be h1 equals to minus half 9.8 tau square. Distance traveled in 2 tau second will be h2 equals to minus half 9.8 2 tau का whole square minus 4 into 1 by 2 9.8 tau square. Similarly, distance traveled in 3 tau second, h3 will be minus 1 by 2 into minus 9.8 into 3 tau ka whole square minus 9 into 1 by 2 into 9.8 into tau square. Similarly, h4 and so on can be calculated. So distance traveled in same interval tau minus 0 equals to h1 equals to s1 minus 9.8 tau square. Distance travel in time interval 2 tau minus tau second. S2 will be S2 minus H1 minus 4 into 1.9.8 tau square minus of 1 by 2 9.8 tau square equals to minus 1 by 2 into 0.8 into tau square under bracket 4 minus 1, which comes out to be minus 3 into 1 by 2 into 9.8 into tau square. Similarly, distance traveled in time interval 3 tau minus 2 tau second equals to S3 equals to S3 minus S2 equals to minus 9 into 1.2 into 9.8 into tau square minus of minus 4 into 1 by 2 into 9.8 into tau square. Finally, we get minus 1 by 2 9.8 into tau square into under bracket 9 minus 4, which comes out to minus 5 into 1 by 2 into 9.8 into tau square. Similarly, S4 can be calculated like this and S5 can be calculated like this. And if we take the ratio, that is S1 is to S2 is to S3 is to S4 dash 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 so on, we get, and putting this value S1 S2 S2, because minus 1.2 9.8 into tau square will be in every term it is contained, so it can be removed. So we are left with 1 is to 3 is to 5 is to 7 is to 7 dot 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 dash dash so on. Proved. Now stopping distance of a vehicle.